Okay, so they give us an integral here, and we get to work backwards here because in this case they're telling us we want the integral to come out to 12. And we have to work backwards and figure out what its upper bound has to be. So let's unpack this and figure out what it's telling us. The function inside is 2t minus 3. So we're talking about the graph of the function y equals 2x minus 3. I could have said t there, but x's are more familiar, and this is a dummy variable, so it doesn't really matter which one we use. That means it's got a y-intercept of minus 3. There you go. Its slope is 2. So it would have an x-intercept here at 1.5. And they're saying we're going to start counting area at 2. That's our lower bound. And that's good news because that means we don't have to worry about any negatives and positives. All the area here is going to be positive. Our area starts at 2, and it goes up, 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 up. And at some point, we're going to get to where the total is 12. And we don't know when that's going to happen. Our left edge is 2 and our right edge is x, and we have to figure out what x has to be. So the integral from 2 up to what of this will give us 12. Let's get that integral done as much as we can, and then we'll see what we can do about this x. So we have the integral from 2 to x of 2t minus 3 dt. So the antiderivative of this is t squared minus 3t plus a constant that I'm ignoring from 2 up to x, which gives us, first we plug in x, which is easy, and then we plug in 2, which is a tiny bit more work. 2 squared is 4, minus 3 times 2 is 6. And so we get x squared minus 3x minus 4 plus 6 is a total of plus 2. And that has to come out to 12. So this looks like it wants to be a quadratic. Let's see if we can solve it that way. Subtract 12 from each side, because quadratics like to be equal to 0. Can you think of two numbers that add up to minus 3 and multiply to negative 10? Perhaps you can, and perhaps you thought of these two. So that means either x could be 5 or x could be negative 2. Interesting. I suppose it could be negative 2 if you had a bit of positive area. Actually, no, I take that back. If this is a bit of positive area, all the area here would be negative. And so I don't see how we could get a total of positive 12 if we went out to the left. I think this answer of negative 2 is one that we'd have to reject. If we did put that into here, we'd get, if we put negative 2, we'd get 4 plus 6 is 10. Oh, yes, it would come. This would work. This would work because over here to the left, do you see what I missed? I was thinking if we went out to the left and had our boundary at negative 2, we'd have positive area here and negative area here, and we'd never make it to 12. But the thing is, if we went this way, we'd get positive area here, and here we'd get area where the heights are negative, but the widths are negative also because we'd be integrating towards the left. So this would come out to be positive area. This little bit would come out to be negative area because we're integrating in kind of the wrong direction. So yeah, it could be negative 2 as our limit. Or the other possibility is we could go in the normal way where we go from 2 up to 5 and get positive area like that. So both of these answers are valid. I don't know if they anticipated that, but either one of these would eventually give you a total of 12. If you integrated from 2 to negative 2 or from 2 to 5, you'd end up with a total of 12. Interesting.